Hi students, in this section we will discuss about Kelvin's bridge. This Kelvin's bridge is mainly used to determine the unknown value of resistance. To determine resistance value we are using here this Kelvin bridge, and especially this Kelvin bridge is used to determine the resistance value whenever the value is less than 1 ohm. That is, the resistance value is less than 1 ohm. In our previous section we have derived expression for balancing condition as well as resistance calculation by using Wheatstone bridge. That Wheatstone bridge is used to measure greater than 1 ohm. But this Kelvin bridge is used to measure the resistance value of less than 1 ohm. Now, it is the simple circuit to determine the value of unknown resistance by using this Kelvin bridge. Here we are having different resistors R1, R2, R3 and Rx. Now we have to determine the value of Rx. And now here it is the galvanometer. Now this galvanometer I would like to connect for 3 points at point A and at point B at point C. At point C. Just look at here. When this galvanometer is connected to point A, this point, when it is connected to here, then RAB, RBC are in series with RX. When the galvanometer is connected to point A, then RAB, RBC are in series with this RX. When the galvanometer is connected to point C, then RAB, RBC are in series with R3. R3. When the galvanometer is connected to point B, then RAB is in series with R3, RBC is in series with RX. That means when it is connected this point, that means the contact is like this right now. Then look at here, RAB is in series with R3, RBC is in series with RX. These are the lead resistances. Lead resistances. And one more point is here, Ry is the resistance between A and C. Ry is the resistance between A and C. So Ry equal to Rab plus RBC. Ry is equal to Rab plus RBC. Let it equation number 1. Equation number 1. Now, in the same manner, the ratio of these two resistances is equal to ratio of these two resistances. That means by depending on that, RBC by RAB equal to R1 by R2. It is equation number 2. Equation number 2. That is equation number 2. And now look at here. I am applying a balancing condition for this bridge. In our previous discussions, we have evaluated the balancing condition. That means simply the product of opposite resistances is equal to the product of another two opposite resistances. So look at here. This is one set. It is opposite to this one, and it is another set. Now because now it is now the point is connected to B. When the galvanometer, when G is connected to point B, G is connected to point B, then what will happen is when it is connected here, this one plus this one into this one is equal to this one plus this one into this one. That means our balancing condition, bridge balancing condition. So with this, I'm writing as this one plus this one, that is Rx plus RBC, these two into R2. That means the product of two opposite resistances is equal to the product of another two opposite resistances, that is R1 into R3 plus RAB. That is equation 3. Now I am performing operation between these three equations. Now consider equation 2. Consider equation 2. Here the equation 2 is this one. So RBC by RAB equal to R1 by R2. Now I am adding 1 on both sides. Add 1 on both sides. I'm adding 1. That means RBC by RAB plus 1 equal to R1 by R2 plus 1. Just I added 1 on both sides. For this equation, I added 1 on both sides. Now I am taking LCM. So RBC plus RAB by RAB equal to, by making LCM here, R1 plus R2 by R2. That is LCM. Now from equation 1 we have some value, RAB plus BC equal to RY. Now I am substituting that value here. That is RAB plus RBC is nothing but RY. So RY by RAB is equal to R1 plus R2 by R2. Now I am taking this RY to this side. Just I am taking this RY to this side. So here is the multiplicand, then I am getting 1 by RAB is equal to R1 plus R2 by R2 into RY. Then now I am inversing 1 by RAB. So I am inversing here RAB equal to, here the term also inverse, R2 into RY by R1 plus R2. It is RAB value. RAB value. Now substitute this RAB in equation 1. Equation 1. That is here the equation 1 is, this is the equation 1. Now we have to substitute that RAB here. That is from equation 1 we have RY equal to RAB plus RBC. It is equation 1. Now I am substituting this RAB. This RAB here I am substituting. So I am getting here RY is equal to, RAB means this much, that is R2 into RY by R1 plus R2 plus RBC is the rest of the term here. Now I am taking this term to this side. This term to this side I am taking. So RBC is equal to RY minus R2 into RY by R1 plus R2. Now I am taking here LCM. So RBC is equal to Ry into this one, R1 plus R2 minus R2 into Ry whole divided by R1 plus R2. Just I am multiplying internally. RBC is equal to Ry into R1 plus Ry into R2 minus R2 into Ry whole divided by R1 plus R2. Here this R2 Ry, R2 Ry get cancelled. Then we're getting RBC equal to Ry into R1 by R1 plus R2. It is RBC. Now I have to substitute this RAB and RBC in equation 3. So substitute RAB and RBC in equation 3. Equation 3. Here is equation 3. So from equation 3, yes, from equation 3, this is the equation 3, Rx plus RBC into R2 equal to R1 into R3 plus RAB. Now I am substituting the values of RBC and RAB here. In these 2 points, I am substituting. First, RBC is equal to, we have RBC here already derived. So first thing, Rx plus RBC is this one, Ry into R1 by R1 plus R2 into R2 is equal to R1 into R3 plus RAB. RAB is nothing but this is the value. This is the value of RAB. Look at here, RAB is this one. So R2 into Ry by R1 plus R2. I have substituted here RAB and RBC. Now I have to simplify these two. So first here I am letting this R2 to this side. So what I am getting is this term as usual, Rx plus Ry into R1 by R1 plus R2 equal to R1 by R2. Here the term will becomes as R1 by R2 into R3 plus R2 into Ry by R1 plus R2. Same term. Now look at here. Rx plus Ry into R1 by R1 plus R2 equal to, just I am multiplying here, R1 R3 by R2. I am multiplying this term with this. Plus, now I am multiplying with them with this. R1 R2 Ry by, within the denominator, R2 into R1 plus R2. Look at here, this R2 will get cancelled. Then I'm getting here Rx plus Ry into R1 by R1 plus R2 is equal to R1 R3 by R2 plus R1 Ry by R1 plus R2. Look at here, this term and this term both are same, so cancel. Then finally we're getting here Rx equal to R1 R3 by R2. It is the balancing. It is the determination of resistance by using Kelvin's bridge. Like this, we can find the unknown value of resistance by using Kelvin's bridge.